Next, alkynes. Alkynes. See, alkynes contains triple bond. Alkynes. Okay. Count the number of carbons. How many carbons are present in this? How many carbons are there? 2 carbons. Okay. So eth. And triple bond is present, ine. So combine these two, ethine, and its common name is very important, acetylene. Acetylene is its common name and it is important. Okay. Next, second one. How many carbons are present here? How many? We have 3 carbons. So propane, I am writing directly propine, and I will give you some bond line structures also. See, give the numbering 1, 2, 3, 4. 1, 2, 3, 4. Triple bond is starting at the first carbon, so this is 1 butane. Total carbons are 4, so 1 butane. Okay, 1 butane, and this is 2 butane. 2 butane. I will send the notes, just you observe. Okay, right. See, in some cases we can see both a double bond and a triple bond within the same molecule, right? Let us cover them. If double bond and a triple bonds are present, okay, here we have some cases. Look at this. Case 1. See, when double bond and a triple bond both are present at the ends, this is case 1, and both are starting from the same point in the sense, see, if we go like this, this is getting 1, double bonded carbon is getting first position 1. If you go like this, triple bonded carbon is getting number 1, that is called same position. Or if both are present at the ends, then priority goes to double bond. If both double bond and triple bond are present at ends, then priority goes to double bond. And one important point, very important point, name always ends with ine. Remember, irrespective of the position of double bond, triple bond, this is generalization. Okay, whatever written with the position of double bond, triple bond, name of this compound means the compound in which double bond and triple bonds are present, its name always ends with ine. Name always ends with ine. So this is the example. Let us see this. First of all, check. Double bond is present at the end. Triple bond is present at the end or not? Clear? Right. In this case, priority goes to double bond. So give numbering to the double bonded carbon. 1, 2, 3, 4, 5. Right? Now, how to give the name for this? First, we should write the root word. What is the root word? How many carbons are present here? 5. So penta. Mention the position of double bond. Pent 1 ene. Triple bond position is, triple bond is present at the 4th. The triple bond is starting at 4th carbon. So 4 ine. We should follow this. Name always ends with ine. See, name is ending with ine or not? That is the rule actually. Okay, we should follow the IUPAC rules. When double bond and triple bonds are present within the same molecule, name always ends with "ine." Yes, we wrote correctly. Clear? First we have to write the root word, we have to mention the position of double bond or triple bond, and name should end with "ine." Clear? Right? Okay. This is about case 1. Case 1 is clear. Case 1 is clear. What is case 1? When double bond and triple bond both are present at the ends. Okay? Right. Case 2. Case 2. If double bond and triple bond are not at the ends, double bond or triple bond, not at end, means if double bond is present at the end, then triple bond is not present at the end. End means corner, terminal. Vice versa. Only one bond is present at the end, other one is not present. Like that. In the last case, what happened? Both are present at the ends. Both are getting 1 numbering. If you go like this, 1. If you go like this, triple bonded carbon is getting 1. This is different case. Now, look at this. If double bond or triple bond are not at end, means both are not at the end. One is present at the end, other one is not present at the end. Other one is present in the middle. Other one is present in the middle. Middle or some other position. Then priority goes to. Then priority goes to the bond which comes first. Bond which comes first. Which will come first, that will get the priority. Look at this. Now double bond is at the end. Sorry, triple bond is at the end. But double bond is not at the end. Double bond is not at the end. If double bond or triple bond not at the end. Here double bond is not at the end. Triple bond is at the end. Anyone is present at the end, other one is not present at the end. In this case, priority goes to the bond which comes first. See, comes first means give the numbering in this direction. 1, 2. Double bond is starting at which position? Second. 1, 2. At second position, double bond is coming. But if you go like this, at first position only triple bond is coming. Which is coming first? Triple bond is coming first. 1. Clear? So 1, 2, 3, 4, 5, 6. If both are at unequal distance, unequal positions, then priority goes to the bond which comes first. Clear? Right? Now what is the root word here? What is the root word here? What is the root word? Hex. Mention the position of double bond. Double bond is at 4. 4 in, and triple bond is at 1. 1 ion. And you should follow the basic rule. What is that basic rule? Name always ends with ion. That is important, irrespective of the position of double bond or triple bond. Name always ends with ion. Got it? Right? Both of you. Okay, right. Now next, let us start the functional groups nomenclature. Yeah, double bond. Which comes first? that will get the priority. Let us start functional group, right? We entered into main part, very important part. Okay, functional groups, nomenclature of functional groups, right? First one, alcohols. Alcohols. What is the general formula of alcohols? Alcohol's general formula ROH, right? Formula. Suffix for alcohols. What is the suffix for alcohols? Ol. Ol. Right? Let us take one example. CH3OH. How many carbon atoms are present? One carbon. So meth. Meth. Is there any carbon-carbon double bond? No. Carbon-carbon triple bond? No. Now consider all the bonds as single bonds. Single bonds. If all are single bonds, then we write ane. Ane. Okay. Plus ol. Why we are writing ol? Because OH group is present. Okay. Right. What is its name? Methanol. Its name is methanol. Okay. Right. Methanol are also called as methyl alcohol. Methanol are methyl alcohol. Okay. Right. Let us see second example. CH3, CH2, OH. How many carbons are present here? 1, 2, 1, 2. Eth plus ane plus ol. Ethanol or ethyl alcohol. Eth plus ane. Why we are writing ane? All are single bonds only. Eth plus ane plus ol, like this. Ethanol, 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 or we can call it as a ethyl alcohol. Ethyl alcohol. And see, you can write this its formula like this: C2H5OH. C2H5OH formula. 2 carbons, and see here 3, here 2, 5 hydrogens, H5 and OH group. Ethyl alcohol, C2H5OH. Clear? Right. Third one, CH3, CH2, CH2. Remember one important point, numbering should start from the carbon atom which is connected to OH group, functional group containing carbon. I told you at the beginning. Okay, give the priority to the carbon atom which is attached to the OH group. So numbering should start from the carbon which is connected to OH group. Clear? Right. Start the numbering 1, 2, 3. OH group is present at which position? First position. See, why we have to mention the position here? I'll tell you. Okay, after taking this example, you will get clarity on it. See this. Both are having 3 carbons only. Both are means this compound is having 3 carbon atoms and this compound also having 3 carbon atoms, right? 3 carbon atoms means if we say propanol, that is enough. Generally, propanol. Clear? 3 carbons are there. Prop plus ane plus ol, propanol. This is propanol. This is also propanol. Na? What is the difference between them? That's why we should mention the position. Position of OH group. Position of OH group. Clear? This is 1 propanol. At first position OH group is present. This is 2 propanol. At second position OH group is present. Okay. What is its name? 1 propanol. 1 propanol. Its name is 2 propanol. 2 propanol. Clear? Any doubt in this? Are you following, both of you? Okay. Right. Now, at the same time, you should know about the bond line representations for 1 propanol and 2 propanol. Let us see the bond line representation. Bond line representation. See, this can be represented like this. 1, 2, 3 carbons we have. So write like this. 1, 2, 3 carbons at and you can write the OH group. 1, 2, 3. 1 2 3 bond line representation. For this bond line representation, like this, 1 2 3 carbons, in the middle OH group is present. Clear? So this type of representation also important. 2 propanol, 2 propanol, both are same, both are same. Okay, right. Now I'll give some difficulty level questions. Okay, these are easy questions, right? Let us start. I'll give you some alkyl groups names. Okay, you have to remember them. One alkyl group I'll cover, then you can remember easily. If I give at a time all the alkyl groups, it is difficult to remember. I'll give you one alkyl group name, so remember, both of you. This part, whenever you observe this type of structure, this type of unit, you have to call it as a tertiary butyl group. Tertiary butyl group. This part, one carbon which is surrounded by methyl by heart. Tertiary butyl 1 2 3 4 carbons. That's why we are calling it as a butyl. Why we are calling it as a tertiary? The middle carbon is surrounded by 1 2 3 carbons, so middle one is tertiary carbon. So tertiary butyl group. So imagine tertiary butyl group means if one carbon surrounded by 3 methyl groups, that is called a tertiary butyl group. Clear? One additional information I am giving to you. Clear? Right. Next example, last example number is 4. Right. Next example, see, fifth example, CH3 right. This is a little bit of example. Let us give the numbering. Before giving the numbering, what we have to do? We have to select the longest chain, right? We have to select the longest chain. Which is longest chain? Longest chain means you should select the carbon chain only. Clear? In that, carbon atom should include. So I can select like this. This is the longest chain because 1 2 3 carbons, longest chain. Now give the numbering. 1, this is second carbon, this is third carbon. Okay, longest chain include carbon atoms. Clear? Don't select oxygen in that chain. Okay, in the main chain, in the parent chain, mostly carbons will be included, not other atoms. Okay, other atoms will not be included. Alcohol, sorry, yeah, correct only, but see, while selecting the carbon chain we include carbons in the chain only according to the IUPAC rule. You asked one good question, why I am not including this OH. You have to include the functional group when it is having carbon. For example, if I have like this, very important rule is select the longest chain. It should include carbon atoms. You have OH functional group. Here you have COOH functional group. In which functional group carbon is present? In COOH. Now you will select like this. If carbon is present in the functional group, then that functional group also included in the main chain. Main point is, in the longest chain, carbons should be present, not other atoms. Okay, in this alcohol there is no carbon, so you should not write like this. Got it? Carbon should be present in the functional group, then we will include that. Clear? Right? Not substituent. Very good question. This is not a substituent, but it won't come in the main chain. It is the parent functional group, main functional group only, but it won't included in the chain. Clear? When functional group is included in the chain, if it is having carbon, if it is carbon, but it is having same priority only. Okay, it should be considered as a functional group only, but it won't be included. Let us see. I'll clear your doubts by giving its name. Got it? Right. Good question. Remember now, very simple confusion. Here only clear picture is there. See, in OH carbon is not there. That's why OH is not included in the numbering parent chain. Okay, but in COOH carbon is there. That's why COOH is included in the parent chain in the numbering. Very simple, right? Alright, let us give the name for this. First of all, we should mention the name of the substituent. What is the substituent name here? What is the substituent name? Methyl. This is the main chain, parent chain. Methyl is not present in the main chain, so it is present out. This is substituent. And what is the position of that methyl? Second position. 2-methyl. Now tell me, alcohol functional group is present at which position? Alcohol functional group is 2. So 2-methyl 2-propanol. Why we are calling it as a propanol? Because in the main chain 3 carbons are there. Propanol. So 2-methyl 2-propanol, and it is commonly called as, common names are very important. You tell me, this part is resembling this CH3 in the middle carbon. So this is tertiary butyl, and this is alcohol. So tertiary butyl alcohol. This is tertiary butyl, that's why I given this. This is tertiary butyl, this is alcohol, tertiary butyl alcohol. Common name is tertiary butyl alcohol. This is very important. In second year, without having idea about nomenclature, you cannot understand even single reaction also. Okay. Now second year students are suffering due to this lag in the nomenclature. Okay, so that's why I'm covering some examples related to second year also. Okay, I'll give you one question to you so that I'll get some idea whether you got the concept or not. Right? You try this, both of you. Try this. Observe the position of carbon which is connected to OH. The OH group containing carbon should get the least number, means this carbon should get the least number. Clear? Means if I go like this 1, 2, 3, third position. If I go like this 1, 2, 3 in same directions, sorry, in both the directions, it is getting same number or not? Correct only, na? Then another consideration we have to take. What is that consideration? The substituent position. So substituent positions. See, if we go in this direction or in this direction, the OH group containing carbon is getting the same number. Then check chlorine. If you go in this direction, chlorine containing carbon is getting 4. If you go in this direction, 1, 2 only. So this is correct. Left to right. Yes, 2 chloro is correct. Okay, right. 1, 2, 3, 4, 5. 2 chloro. 3 3-pentanol, 3-pentanol, 2-chloro-3-pentanol. Got it? Right. And one more important example we have. See, when double bond is present in combination with any other functional group. When double bond is present in combination with any other functional group, means double bond alcohol, double bond aldehyde, double bond ketone, double bond carboxylic acid. Clear? Double bond should get the least priority. Don't start numbering from the double bonded carbon. Clear? When double bond is present in combination with any other functional group, that functional group only will get high priority. Double bond should be least. Double bond or triple bond, these two are always will get least priority. Some students will start like this: here double bonded carbon is present, so let us give the numbering in this direction. That is wrong. That is wrong. You should give numbering in this direction only. Okay, because OH is a high priority functional group when compared to double bond or triple bond. Clear? So OH group containing carbon will get high priority. So start from that. 1, 2, 3, 4. This is correct. Clear? Right. remember now onwards, when double bond and other functional group came, first write root word bute, 4 carbons, bute. What is the position of double bond? Double bond is starting at which carbon? 3rd carbon. Bute, 3-ene, bute, 3-ene, 1 ol. Very important. First write the root word, mention the position of double bond, mention the position of alcohol. Right? Clear? And we can represent this in the bond line form like this. Both are same only. 1, 2, 3, 4. Both are same. Clear? Right. Next I am giving another group. You know about tertiary alkyl group? What is tertiary alkyl group? Tertiary butyl group. 1 carbon if surrounded by 3 methyls, the total group is called as tertiary butyl group. Tertiary butyl group. This is tertiary butyl alcohol. Similarly, I am giving another important alkyl group. If 1 carbon is surrounded by 2 methyl groups, 1 carbon surrounded by 2 methyl groups, that is called as isopropyl. That is called as isopropyl group. Okay. So if I add OH group, here, then it is generally called as isopropyl alcohol. Because this part is isopropyl, this is alcohol. Isopropyl alcohol. Can you give it IUPAC name? This is common name. What is its IUPAC name? Give the numbering. This is the longest chain, na? 2-propanol. Already we did this. 2-propanol. This is the longest chain. Clear? See, I'll give you practice sheets to you. After doing them, you will get perfection. Clear? But first of all, you should expose to some different types of questions, not limited models. Okay, you may not get at a time. By listening one time, you may not get. But what is important point? Doing the questions, doing worksheets. That is very, very important. I'll make you to do the questions day after tomorrow. Okay, I have holiday, you also have holiday na, so you will come to home tuition, then you will do the questions. Okay, then you will get perfection. In the meanwhile, you complete the rules. Okay, just go through the notes. It will take some time. Okay, for nomenclature, means I'm injecting all the concepts at a time onto you. Actually, instead of going in the slow way, actually that is correct, but we do not have time now. That is the reason. So just listen casually. Clear? Right. Now in all calls, I'll cover cyclic category, cyclic examples. Cyclic. What is its name? What is its name? Can you give its name? Cyclohexene. Cyclohexene. If I attach OH group, then cyclohexanol. Yes. Cyclohexanol. Cyclohexanol. This is the parent compound. Remember, cyclohexanol is the parent compound. Now I'll give some other examples. Right. My first question, will we follow lowest locant rule in this case, or we start the numbering from the carbon which is attached to OH group? Give me clarity. Will we? Yes. We should start from the carbon which is connected to OH group, because OH is the main functional group. OH attached carbon will get high priority. So you should start the numbering from the OH group containing carbon. OH group containing carbon. This is OH group containing carbon. 1. After that, you tell me I should go like this, right side or left side, which is correct? Right side or left? Why right side? Why not left side? 1, 2, 3. 1, 2, 3. If I go like this, 1, 2, 3, 4, at the fourth position, I'm getting substituent. Clear? Right. 1, 2, 3, 4, 5, 6. Okay. Right. Let us start the name. Right. 3-methyl. Is it correct? Tell me. 3-methyl, 4-ethyl. Is it correct? Cyclohexanol. Is it correct? Correct only, is it? Correct? Correct? Not correct. Yeah. Numbering is correct only. But writing the name is not correct. See, arrange the names according to alphabetical. Numbering is correct, but naming is different. Wrong. Okay? Right. Four ethyl, 3-methyl. Now parent compound. Parent compound is this part, cyclohexanol. This one, cyclohexanol. Cyclohexanol. Right? Okay. Can you try that one? I'll wait. Try that. See. 1. We can go in two different directions, right? 1, 2, 3. 1, 2, 3. In two directions, substituted carbon is getting 3 only. But what is its name? Ethyl. Its name is one carbon only there, methyl. Letter E comes first. 1, 2, 3, 4, 5, 6. Right? So 3-ethyl, 4-methyl, cyclohexanol. cyclohexanol. Got it? Five ethyl. 5, yeah. 5 or 4, what? No, what I wrote here? 5. Actually, I given correct numbering only, but while I am writing, I did mistake. In this direction. In this. No, wrong. Why? Because when two substituents are at the same positions, then follow alphabetical order. Okay. 1, 2, 3. Both are presented third only. Then follow alphabetical order. Now, next. Aldehydes. What is the suffix for aldehydes? Al. Suffix for aldehydes is al. Okay. Right. HC double bond OH. It is also represented like this, simply HCHO. Okay. Aldehyde. How many carbons are present? 1 carbon is present. Meth. Is there any carbon-carbon double bond? Carbon-carbon between 2 carbons. Is there any double bond? No. Carbon-oxygen is there, but carbon-carbon not there. When carbon-carbon double bond, carbon-carbon triple bonds are present, then only we write ene or ine. Otherwise, we write ane. Meth plus ane plus all. Read all by combining methanol, and the common name is most important, right? In the second year, these names will come. Formaldehyde. Common name is formaldehyde. Okay, right. Second one. CH3CHO. See, we can write like this also. CH3 C double bond OH. C double bond OH means that is CHO. C double bond OH means CHO. This is CHO in the expanded form. CHO can be expanded like this. C double bond OH. Don't get any confusion. Okay, right. How many carbons are present to count carbons? 2. And one more important point, numbering should start from the functional group carbon only. Here, functional group carbon is getting high priority. Remember that point. You should start from the functional group carbon. Numbering should start from the functional group carbon. So 1, 2. 2 carbons are there. Eth plus ane plus all ethanol. Methanol and ethanol. 2 carbons are there. Eth plus ane plus all ethanol, and commonly it is called as acetaldehyde. Acetaldehyde is its a common name. Okay, right. Now I'll increase the depth. Some difficult level questions. We have 3 carbons, right? Numbering should start from the functional group carbon always. And knowing bond line structure is very important point. You can write like this. 1, 2, 3. Both are same only, no? You should know about the bond line more rather than the normal representation, because we'll get most of the questions in the bond line only. So whenever you get in the terminal at the end, terminal means at the end, C double bond OH, that represents aldehyde. This is C double bond OH, this part represent aldehyde. You have to imagine aldehyde. Okay, right. Can you give its name? Can you give it say? Propanol. 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 All AL all aldehyde. Propanaldehyde. Okay, right. First of all, tell me which functional group is present in it. Which functional group is present in aldehyde? Because terminal C double bond OH, terminal C double bond OH, aldehyde is present. Okay, so one aldehyde. This is aldehyde carbon. Numbering should start from the aldehyde carbon only. 1, 2, 3, 4, 5. Right? First mention the names of the substituents. 3 bromo, 2 chloro, 3 bromo, 2 chloro. Total how many carbons are there? 5. Pentanol. 3 bromo, 2 chloro, pentanol. Clear? Got it? Right. Can you try this? First of all, tell me, the functional group is aldehyde or not? Any doubt in this? Because at the terminal C double bond OH. Right. Now try the name for this. Yes. One functional group carbon should get high priority. 1, 2, 3, 4, 5, 6. First mention the name of the substituent. 2-ethyl. When double bond is present in combination with other functional groups, first we write the root word Higgs. 2-ethyl Higgs. Yeah, 3 in 1 all. Or you can write like directly 3-hexenol also you can write, or 3 in 1 all, or 3-hexenol also correct. Follow this one. Okay. Now very important point. This symbol represent very important danger. $100 volt current, 1000 volt current. Now onwards I'll give you symbols like this. 100 volt means important, 1000 volts means most important symbols. This is ghost rider. Flames. Very important point or important example we are going to discuss. Okay, right. Can you try its name? Any idea? Yeah, almost near there. Right. See, up to now we wrote the names like this: methanol, propanol, yes, propanol, hexanol. But here all won't come. Special name will come. Why special name will come? Let us see. First of all, give the number. Start the number 1, 2, 3, 4, 5. Right? Okay. Now I'll ask you one question. In my class, you both are the students. I have only one chocolate. Okay, you came to my room. You sat in my room. I have only one chocolate. To which I have to give the chocolate. For Sarah or for Asma. I have only one chocolate. What is the best solution? I should not cut. I should not break. What is the best solution for it? That is the best solution. Best solution, clear? Because if I give chocolate to Sarah, then Asma may feel. If I give chocolate to Asma, Sarah may feel. So the best solution is I have to eat instead of giving one chocolate to any one of. Clear? Similarly, aldehyde, aldehyde, aldehyde. We have three functional groups, right? Both are same only now. Why you are giving number 1 to one aldehyde? First position, ranking 1, super first. Fifth rank, last. And this is not getting any rank also. Why this partiality is showing here? Clear? If you start 1 at this position is getting 5. It is not correct. All are same only, na? All aldehydes only, na? Why you are giving last priority to one aldehyde, first priority to other aldehyde, and you are not giving any number to middle one? This is not correct. So in order to avoid the ambiguity, don't start the numbering from the aldehydic carbon. In the last cases, see, we started numbering from aldehydic carbon. Every time we started numbering from the aldehydic carbon. Now, we should not start numbering from the aldehydic carbon. That is the best solution. Don't give numbering to any aldehyde, Now how to give that? See here. 1, 2, 3. Over. You didn't give numbering to any aldehyde. Problem solved. But how to give the name? When, very important point, when functional group carbon is not included in the numbering. When functional group carbon is not included in the numbering, special word will come, that is carb. See. Here functional group carbon is included in numbering, there is no term, carb term. Clear? In the last case also, functional group carbon is included in the numbering. So, just all. There is no word carb. But here functional group carbon is not included in the numbering. So, special word will come. So, that is carb. I'll write that point. When functional group carbon is not included in numbering, then special word carb, highlight this, will come in the name carb. Okay. No. How to give the name for this? See, 1, 2, 3. 3 carbons are present in the main chain. 3 carbons. So propane at the first position, at second position, at third position. At third position, aldehyde is present. So propane 1, 2, 3 tricarbaldehyde. Carbaldehyde. Very important. This option also will come. Trial. Propane 1, 2, 3 trial. That is wrong. All won't come. When all will come? When functional group carbon is included in the numbering. Clear? Propane 1, 2, 3 tricarbaldehyde. Carbaldehyde will come. Clear? Any doubt in this? Tell me. Right. I'll give you. You try this. You try this. Try this. Any one of you. Try its name. Very good. Butane 1 comma 2 comma 4 tricarbondehyde. Very good. Good. Super. Right. Similar to this nomenclature, very important example is there. Another example similar to this. Here I'll give you one hint. You tell me in the ring, how many carbons are present? 1, 2, 3, 4, 5, 6. How many carbons are present in the ring? How many carbons? 6. In the ring, 6 carbons are present. And you tell me functional group carbon is included in the ring or it is present outside? It is present outside. Functional group carbon is present outside the ring. This carbon is outside the ring, not included in the ring, not included in the cyclic ring. Right? Yes or no? Any doubt? In this case also we use that special name carb, because functional group is out of the ring. So its name is cyclohexane carbaldehyde. Here also special name will come. Why? Because functional group is not included in the ring, Clear? Cyclohexane carbaldehyde. Very important. In 2 cases we use carb. When functional group is not included in the numbering, like this, you didn't start numbering from the functional group carbon. What is another case? When functional group carbon is not present in the ring, if it is out of the ring, then also we use special word carbaldehyde. Got it? Okay? Right. Its common name is very important, glyoxal. In second year it will come glyoxal. In first year also it will come glyoxal. And IUPAC name is ethane 1,2 diol. Because functional group carbon is included in the numbering. So all functional group carbon is included in the numbering. All. Ethane. 2 carbons are there. That's why ethane 1,2 diol. Ethane 1,2 diol. Commonly it is called as glyoxal. Clear? Got it? Right. Ketones. What is the general representation of ketone? RC double bond OR. Okay. What is the suffix for ketones? Ketone suffix. Tell me ketone suffix. On. Right? How many carbons are present in this? 1, 2, 3. 3 carbons. 1, 2, 3 carbons. So prop plus ane plus one. Prop plus ane plus one. Propanone. Prop plus ane plus one. Propanone. Okay. Also called as very very important, acetone, 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 propanone or acetone, propanone or acetone. Second one, you can write like this also, bond line representation. I forgot to give bond line representation. Both are same only, CH3 C double bond O CH3, these two are same. Okay, right. Second one, you can write like this also, CH3 C double bond O CH2 CH3, both are same, both are same. How many carbons are present? 4. Butanone, butanone, butanone. Can I write like this? Is it correct if I write like this? If I write like this, is it correct? 1 2 3 4, 2 butanone, 2 butanone. Now you tell me what happens if I write this C double bond O this side. Say its name. I'm changing the position of C double bond O. Then what is its name? 1 2 3. Correct only, no? 3 butanone, right? Right? Tell me. Very good. Super. Correct. 1 2 3 4. Then what is its name? Its name is 2 butanone only, no? One name for two compounds. This is not correct. These two are similar only. So see, when we should mention the numbering, when we should not mention the numbering. See, when you change the position of functional group to some other place, if you get same name, then no need to mention the position. You should not write 2. Nothing will happen if you do not write 2, because if you change the position of C double bond O, then nothing is happening. You are not getting any new name. Clear? You are getting 2 butanone only. So you no need to mention the numbering. I'll tell you when you have to mention the numbering. You can cut to right. Let us see this example. First of all, give numbering 1 2 3 4 5. 1 2 3 4 5. When carbon number is 5 or greater than 5, in case of ketones, I am talking in case of ketones, we should mention the numbering. 4, below 4, you no need to mention. See, I didn't write like this, 2 butanone or 2 propanone. I didn't write. Clear? When carbon number is below 5, you no need to mention the position. 5 above 5, then you have to mention the numbering. Numbering in the sense where C double bond O is present. Clear? Right. What is its name? 2-pentanone. 2-pentanone. When you shift this C double bond O to this position, it will become 3-pentanone. So you are getting different name, different numbering. No. For bifunctional means, how can I say? Look at this. Some terminal functional groups are there. For example, aldehyde is there. CHO, CH2, CH2, CH2. You should start from the functional group carbon, right? Ketone is there. You asked one good question. In case of ketone, the numbering scenario is like this, either this end or this end only, not like this, not like that. Is the rule, that is the rule, right? For few on practice you will get. Clear? For ketone you should start from this end or this end, but not, because this is internal functional group, not the terminal. Aldehyde is the terminal, na? So you can start from the end, this end to that end. But this internal functional group. Yeah, terminal functional groups. Terminal. Terminal means that are present at the end. Ketone is internal. C double bond O is present in the middle. You should start from this end or this end not. Okay, right. 3-pentanone. Is it clear? Any doubt in this? 3 and 4 examples. Sarah, got it? Right. Now shall I give one tough question to you? Start. Try this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Where is ethyl? This ethyl you are saying? This is the longest chain, na? Longest chain. Longest chain. Right. See. You have 3 methyls. Where? At which position? At the 5th position, 2 methyls. At the 7th position, 1 methyl. And you have ethyl at the 3rd position. Right? Okay. 3 ethyl, because E letter comes first. 3 ethyl, 5, 5, 7 trimethyl. Total how many carbons are there? 9. And ketone is present at the 2nd position. 2 known, butanone, pentanone, hexanone, heptanone, octanone, non-known. Okay. If 3 are present, you write propanone, 4 butanone, 5 pentanone, 6 hexanone, 7 heptanone, 8 octanone, 9 nonanone. Okay, 9 carbons are there. Okay, right. One tough question I give it. Got it? Yes. This is cyclohexanone. Cyclohexanone. Very important name. Remember this. Cyclohexanone. Ketone is there, no? That's why hexanone. Right. Next. Carboxylic acids. Aldehydes, ketones, carboxylic acids. What is the formula? RCOOH, or you can write like this, RC double bond OH. Carboxylic acid, or whenever you observe this unit at the terminal, C double bond OH, this unit represent COOH. Okay, right. First example, HCOOH or HC double bond OH. One carbon is there, meth. There is no carbon double bond, so ane. And in case of carboxylic acid, what is the suffix? Oic acid. So plus oic acid. So methanoic acid. Commonly it is called as formic acid. Very, very, very important. Common names are very, very important. Formic acid. Okay, right. Second one, CH3COOH, or you can write like this also, CH3C double bond OH. Both are same, expanded form and normal form. Okay, just a second. Okay, let us continue carboxylic acids. Are you there, both of you? Hello? Right. What is its name? What is its name? Acetic acid. Acetic acid. Or what is IUPAC's name? IUPAC's name? Ethanoic acid. Ethanoic acid. Correct? Right. Now can you try? How many carbons are present? How many carbons are present? Propanoic acid. Propanoic acid. Fourth one. CH3, CH2, CH2. What is its name? Butanoic acid. 1, 2, 3, 4. Butanoic acid. Butanoic acid. And see, if 4 carbons are present in the carboxylic acid, that is called as butyric acid. That is called as butyric acid. Butyric acid. If 4 carbons are present, that is called as butyric acid. Butyric acid. Right? If 5 carbons are present, for example, if you have 5 carbons like this, IUPAC's name is pentanoic acid, no doubt. What is its name? What is its name? Pentanoic acid, because we have 5 carbons. 1, 2, 3, 4, 5. Pentanoic acid. Pentanoic acid. Its common name is valeric acid. Common name is valeric acid. Valeric acid. So, which carboxylic acid is called as valeric acid? Carboxylic acid with 5 carbons. Valeric acid. Which carboxylic acid is called butyric acid? Carboxylic acid with 4 carbons. Okay? Clear? Any doubt in this? No? Right. See. Can you try its name? Can you try? What is the name for this compound? 1. This is carboxylic carbon. 1, 2, 3, 4. Okay. But 3 in 1 oic acid, or you can write like this also. 3 butanoic acid, or 3 butanoic acid. 3 butanoic acid. Clear? This is functional group carbon. Functional group carbon. Right. Valeric acid, butyric acid. Clear? Right. Now, who will give the correct answer for this example? I explained clearly about this. It is very similar to one compound in aldehydes. We will give the name for this. Oic acid means carba. Special word, yes. Special word will come, yes. Propane 1, 2, 3 tricarboxylic acid. Tricarboxylic acid. Propane 1, 2, 3 tricarboxylic acid. Carbaldehyde, because aldehyde na, so carba plus aldehyde, carbaldehyde. Carba plus acid, carboxylic acid. That is aldehyde. That's why carba plus aldehyde, carbaldehyde. This is acid. Carba plus acid, carboxylic acid. Clear? Right. Now, yeah. Tell me, what about this? Cyclohexane carboxylic acid. Cyclohexanoic acid is wrong answer. Asma? Correct. cyclohexane carboxylic acid. Cyclohexane carboxylic acid. Because in the ring, carbon is not included. Which carbon? Functional group carbon. So special name carboxylic. Carboxylic. Okay, right. Next. Oh my such good apple. Oh my such good apple. Oh my such good apple. See, COOH. Between these two COOH, is there any CH2? No. Zero. That's right. Zero. Zero. And O, alphabet O. Next, COOH, CH2, COOH. In the middle, CH2 is present. In the middle, CH2 is present. One second. COOH, CH2, CH2, COOH. How many CH2 groups are present in the middle? 2. CH2 units, 2. Now, COOH. Now, I am writing like this. CH2 taken thrice. Means in the middle, 3 CH2 units are present. Here, COOH, CH2 taken 4 times COOH. How many? 4 CH2. 4 CH2. Clear? Right. See, O in 0 CH2. My 1 CH2. Such 2 CH2. Good 3 CH2. Apple 4 CH2. Okay. Oxalic acid. Oxalic acid. O, starting with O, no, oxalic acid. 1 CH2. M. See, O my such good apple. 0, 1, 2, 3, 4. Oh my such good apple. 0, 1, 2, like that. Okay. 1. Oxalic acid. Malonic acid. Malonic acid. Malonic acid. Okay. Succinic acid. Succinic acid. All these are common names. Succinic acid. Glutaric acid. Glutaric acid. Adipic acid. Adipic acid. Adipic acid. Oxalic acid, malonic acid, succinic acid, glutaric acid, adipic acid. Oh my such good apple code. Got it? Both of you. Clear? Cyanides. Small functional group. This is cyanide. Formula is RCN. Suffix is alkane nitrile. Okay. See first example. CH3Cl. In this, how many carbons are present? 1, 2. So ethane nitrile. Okay. In this, how many carbons are present? 1, 2, 3. Propane, 1, 2, 3. 3 carbons are there. Propane nitrile. Alkane nitrile is the common name. Propane nitrile. Okay. Right. Can you give its name? Carbonitrile. Carbonitrile. Third one is important. Very small topic. Can you try this? Cyclohexane carbonitrile. Cyclohexane carbonitrile. cyanides or nitriles. Okay, right. One of the important functional group is esters. Most of the students will get confusion and difficulty in esters nomenclature. Majority of the students. Okay, esters, and important also. So you may do mistakes. Esters are C double bond O R. Ester R C double bond O R. Now, what is the suffix? What I taught? What is the suffix? Alkyl, alkanoate. Okay, what is alkyl, what is alkanoate? See this, very easy if you follow this trick. See, the R group which is attached to single bonded oxygen, this one is alkyl part. This is alkyl, and the remaining part is alkanoate part. First you have to mention this one, after that this one in the sequence 1 2 means alkyl, alkanoate. First you should write a name of alkyl group which is connected to single bond oxygen, whatever it may be the ester, whether it is having substituent also. If substituents are present, then also first you should write this one only, alkyl part name only. That is the importance of ester. Generally, if substituents are present, we write 2-chlorobutane or 4-bromopentane. First we mention the name of substituent, but the importance of ester is irrespective of the substituent. If substituent is present, then also first we write alkyl part name. I will give you one example. You will get clarity on it. See. This is alkyl part, right? One carbon is there na, methyl. Here how many carbons are there? Give numbering. 1 2. How many carbons are there here? How many carbons? 2 carbons are there. Alkyl, methyl. Tell me alkanoate. Alkanoate means ethanoate. Methyl ethanoate. Alkyl, alkanoate. Let us see some other. No. Just we say the name only. Okay, right. Look at this. C2H5. C2H5. Now try this. First, what we have to write? Name of alkyl part. This is alkyl. What is its name? 2 carbons are present. So this is ethyl. Alkyl, alkanoate. How many carbons are there here? Numbering should start from the ester carbonyl carbon in this direction. Propanoate. Very good. Ethyl propanoate. Right. Or I can draw this structure like this also. Both are same only. So this is ethyl 1 2 3 propanoate. Ethyl propanoate. Try this. Try. You can write bond or you can write directly. Both are same only. Tell me. Try. First rule is writing alkyl. Methyl. That is the rule. Methyl. 1 2 3 4. Now substituent is present at a third. Methyl 3 chloro 1 2 3 4 butanoate. No 8. Okay. Now one important example. Who will give the answer for this? Try this. Methyl. How many carbons are there here? One only. Methyl methanoate. Methyl methanoate. Commonly it is called as methyl formate. Methyl formate. Methyl methanoate. Commonly it is called as methyl formate. Methyl formate. Amines. First of all, you should know the classification of amine. Amines are classified into primary amine, secondary amine, and tertiary amine. What is a primary amine? If one alkyl group is present, that is primary amine. If two alkyl groups are present, then that is secondary amine. If three alkyl groups are present, that is tertiary amine. Tertiary amine. Okay. See example CH3NH2 primary amine, because this is one alkyl group. Two alkyl groups, CH3 taken twice NH, two alkyl groups. 3 CH3 taken thrice N, tertiary amine. Tertiary amine. Okay. Or you can remember like this also. If nitrogen is connected to one bond, one R group, one bond, here hydrogens are not considered as a groups or bonds. If it is connected to one line or one bond, hydrogen is not considered as a bond. Just remember like that. Primary. If nitrogen is connected to two lines, remember hydrogen is not considered as a bond. This is one bond, this is one bond. Don't think like this are hydrogen also bond, now three bonds. Hydrogen with hydrogen, just imagine there is no bond. If nitrogen is surrounded by 3, that is tertiary. Tertiary means here one R will come, this side one R will come, this side one R will come, R. Or simply remember like this: one R group primary, two R groups secondary, three R groups tertiary. Here I given the structure format. Okay, so amines are classified into how many types? 3 types: primary, secondary, and tertiary amines. Clear? Let us start first one. What is the suffix for amines? What is the suffix for amines? Amines suffix. Suffix for amine. Alkanamine. 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 Methanamine, ethanamine, propanamine, like that. Okay, first one. Methanamine. Methanamine. Second one. Ethanamine. 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 This is tell me third one. Fourth one. Propanamine होंगे ना? One. Yes, correct. Prop two amine or two propanamine. This is one propanamine. One propanamine. This is two propanamine. Two propanamine. One propanamine, two propanamine. Okay, right? Clear? Now you tell me, this is primary or not? 1 degree. Because see, to the nitrogen left side only one line is there. One line. See this. Left side one line, primary. One line only. Nitrogen is connected to one line, primary. primary. This is primary. Nitrogen is connected to one line only. Primary, one line primary. Two lines, that side, this side. Secondary, three lines, tertiary. Remember that. Okay. Now let us start secondary amines. Secondary amine examples. All that are primary amines, secondary amines. CH3, CH2, CH2, NHCH3. See, in this case, nitrogen is connected to two side chains. Right side one side chain, one chain. Left side one chain. Which chain is having more number of carbons? Which chain? Left hand side or right hand side? Left side. So this is considered. This is considered as a parent chain. Parent chain, and this will be considered as a substituent. Substituent. So you should mention the name of the substituent. You should mention the name of the substituent. First write name of the substituent. Now you tell me substituent is attached to nitrogen or not here? Substituent. See how to give the 2-degree amines names. Methyl is connected to nitrogen. Methyl is present on the nitrogen head. Connected to nitrogen head. So N-methyl is a different naming. Why we are mentioning N? Means methyl is connected to N. So N-methyl. N-methyl. Methyl is connected to nitrogen. Then coming to the parent chain. In parent chain, how many carbons are there? 1, 2, 3. N-methyl propanamine. N-methyl propanamine. Amine is alkanamine is common, na? Alkanamine. So propanamine. Substitute name and the main name. Clear? Now you try this. And one more, I forgot to give the bond line structure. Both are same. Methyl, N-methyl, 1, 2, 3, propanamine. Propanamine. You try this. Give the name for this. Give the name for this. N-ethyl butanamine. Good. N-ethyl butanamine. N-ethyl butanamine. How can we draw in the bond line representation? 1, 2, 3, 4. Right? 1, 2, 3, 4, and 1, 2, and hydrogen. Right? Now 3 degree. Coming to 3 degree. This is methyl, this is methyl. 2 methyls and 1 propyl group. So these two are substituents. N comma N dimethyl. N comma N dimethyl. N comma N dimethyl propanamine. 3 degree amine. N comma N dimethyl propanamine. What is its degree? 3 degree. Clear? NN dimethyl propanamine. Now can you try this? Can you try? Make it fast. What are the substituent names? What are the names of substituents? What? Yeah, tell me. Yes. N-ethyl, because see, this is ethyl. 2 carbons are there. Ethyl, E comes first. N-ethyl, N-ethyl, N-methyl, 1, 2, 3, 4, butanamine. Butanamine. Got it?